20. Identify the atoms that are oxidized and reduced, the change in oxidation state for each, and the oxidizing and reducing agents in each of the following equations. And then we have the first equation out of the bunch. We have magnesium solid plus NiCl2 aqueous will yield magnesium chloride, MgCl2, and then plus nickel solid. Okay, so they're asking us to find out oxidation states and what atoms are being oxidized or reduced. So I know that this equation has to be a redox reaction. Oxidation-reduction reactions are ones in which the elements change state or change charges from reactant to the product. So if you ever see a change in oxidation state from the same element from the reactant to the product, it's automatically a redox reaction. But now we just have to find out which one out of the bunch was oxidized and which one was reduced. So backtrack a little bit, right? Just know the difference between what it means to be oxidized and what it means to be reduced. And I wrote that down for you over here. You can remember the mnemonic Leo, the lion says grr. That's how I learned it as a kid. So if it worked for me, it might work for you. So Leo the lion says grr. Leo, L-E-O, loss of electrons is always oxidation. And then the grr side is the reverse. Gain of electrons are reduction. So loss of electrons, oxidation. Gain of electrons are reduction. Now remember, the key thing here is that electrons are negative. So if you are becoming more positive, you are losing electrons. You're undergoing oxidation. And if you're gaining electrons, and electrons are negative, you're becoming more negative. Now just know that the one that is oxidized is the reducing agent. When you put the word agent in there, it's actually the opposite meaning. So if your compound is undergoing oxidation, you are the reducing agent. You are the compound or the molecule that helps the other one be reduced. And then vice versa, if you're undergoing reduction, you are classified as the oxidizing agent. I don't know why I put oxidating agent. It's oxidizing agent. So oxidizing. I think I could fit that in there. Oxidizing. Perfect. Okay. So now we're ready to go. Let's find out these charges. We've done tons of problems already figuring out how to find the charges of each individual element. So this will be a breeze, right? So let's just work from left to right. The first thing we got magnesium, right? And remember, if you have an element all by itself without a charge in the upper right-hand corner, these are neutral. And what is the number that is not positive nor negative? It's a 0. So the oxidation state for magnesium would be a 0. And I'll put like a slash here because it's not oxygen. Oh, it's a 0. So I'm just going to put the number up here. Now I have a compound. I have NiCl2. So I have to find out what that is. And remember, we could just do the crisscross method to find out the charges. There was 1 nickel here, right, and 2 chlorines. These subscripts will get crisscrossed up to let me know what the charges were. So this 1 crisscrosses back up to chlorine, telling me that it was a -1 charge, right? And remember, standard negatives are in the back. And then this 2 crisscrossed up, telling me that the nickel was a +2 when this compound was formed. So I have nickel 2 plus or +2, whatever you want to put, and then a Cl -1. Now that's why I put this charge, the periodic table trends over here, because always just make sure that you have the right trend. All you got to do is just match one of them up, and if that one is the same, then the other one is the same as well. So meaning chlorine should be a -1, right? And on my chart, and by the way, memorize this trend, okay? Your oxidation states. But you've probably seen this chart already if you've been doing the problems with us. But over here, right, here's chlorine. And chlorine is in the group that has a -1 charge. So if this checks out, this one checks out as well. So I'm just going to put those numbers up here. Nickel was a +2 and chlorine was a -1. Okay, moving on. We're going to do the same exact thing. We got MgCl2. This is a compound, so we have to have charges. Use those subscripts. There was 1 magnesium, 2 chlorines. So crisscross the back up. The 1 crisscrossed to chlorine, telling me that that was a -1. And the 2 crisscrossed back up to magnesium, telling me that magnesium was a +2. So when this compound came together, magnesium was a +2 and chlorine was a -1. And both of these are on your oxidation state trend, right? Magnesium is over here. It's in group 2. And just like we said before, the chlorine is the -1. So I'm just going to put those charges up here. So +2 and -1. Now we have little old nickel by itself. Remember, any element by itself that does not have a charge up here is neutral, so 0. So this guy would be a 0 charge. And I'll just put a 0 up here. Okay, now we're ready to answer the questions. When they say identify the atoms that are oxidized and reduced, we're looking for the individual elements. So let's see what changed. Magnesium went from a 0 charge to a +2. You see that? 0 to a +2. That's why I like to put the charges on the top, because everything is right here for me to look at. And I'm just going to write that down. I'm going to say that magnesium went from a 0 to a +2. And maybe I'll put it over here because I want to write some more things. Let's see, did anybody else change? Nickel went from a +2 to a 0. So there we go. Okay, so maybe let's change this back. Actually, let's try to maybe, yeah, just so that I can get that line going down. So nickel went from a +2 all the way to a 0. So maybe I'll just write this on the side over here. Magnesium went from a 0 to a +2. And nickel went from a +2 to a 0. And now let's just look at chlorine. But chlorine on both sides was a -1 or a -1, and it didn't change. So in this case, I don't have to write down what magnesium's doing. So now we have 2 atoms, right? I got magnesium and I got nickel. I need to find out which one was being oxidized and which one was being reduced. Remember, the one that's being oxidized or undergoing oxidation loses electrons, aka it's becoming more positive. So let's see, which one out of these 2 became more positive? Magnesium, right? It started off with a 0. If you think of it as a number line, if you're going to a +2, you're becoming more positive. So magnesium was the one that was being oxidized. Which, in return, which one was being reduced? Nickel, right? The one that's undergoing reduction is the one that goes to the left of a number line. It's the one that gets more negative. And you started at a +2, and you went all the way to a 0. So this has to be reduced. So that answers the first question. Magnesium is the one being oxidized. That's the atom. And then nickel is the one that's being reduced. Okay. Now we just want to say the change in oxidation states. We did that already. The change in oxidation state for magnesium was it started at a 0 and it went to a +2. That's the change. It became more positive. Nickel, on the other hand, the change in oxidation state, it started at a 2 and it went to a 0. So those are your answers for that. And now we just need to say which one is the oxidizing and which one is the reducing agent. Now the thing is here, remember, the one that was being oxidized is the reducing agent. The one that was being reduced is the oxidizing agent. And the trick here is that your oxidizing agents and your reducing agents, they can only be the reactant side. You can never have oxidizing agents or reducing agents on the product side. So you already eliminated two choices. One of these has to be the oxidizing agent, and one of them has to be the reducing agent. When we're talking about oxidizing and reducing agents, you take the whole compound as a whole. But the one that was being oxidized will tell you who's the reducing agent, and the one that's being reduced will tell me who the oxidizing agent is. So since magnesium was being oxidized, the reducing agent, because they go together, the reducing agent was this guy. It's the one that has the Mg in it. So just be Mg, and if you want to put a solid there, go right ahead. Nickel, since it was reduced, you take the compound that has the nickel in it. So the oxidizing agent, which is the one that was being reduced, is NiCl2, and that's aqueous. If you want to put the state, that's fine, but technically the compounds is the only thing that matters. So there you go. What do you think, guys? Not bad. A lot of things in this question, but take it slow, step by step, and you guys got this, all right? So let me know what you think. Give this video a thumbs up if it helped, and subscribe to the channel if you would like to. That would help us out, and thank you so much for that. But as always, I'll see you guys in the next lesson, and I hope you have an awesome day. Bye-bye.